So, you want to create a smooth, responsive movement for your game? You are in the right place. Movement is crucial in games since the player will be moving almost constantly. In isometric games, movement is a bit different than in other games, so let's dive in. We'll be using Unity 6.0, the new input system, and a character controller for this setup. We'll implement a standard movement, acceleration and deceleration, dashing, and handling uneven terrain. I've already set up my camera. Check out the video link in the description for details. First, we need to get input from the player. Let's install the new input system package. It's the default in Unity 6.0, but if you're using an older version, install it from the package manager. There are several ways to capture input, but we'll create a class specifically for it. You'll see an asset for the input system in the assets main folder. Check the inspector for generate C# class and then click apply. Now we can use it like any other class in our code. When you click 2 times on the asset, there will be a new window. In this asset, there are 2 default action maps for UI and for player inputs. Movement for gamepad and keyboard is already set up, so we have covered here. If you own an older version, I'll cover how to create new input actions in the next video. Next, let's create a player controller script. Select your player in the hierarchy, add a component, type player controller, press 2 times enter, and open this player script. Delete everything in the script to start fresh. First, let's create an object of input system actions. Define a variable, private input system actions, player input actions. In the await method, let's create it like we create any other class. Just like that. And in the onEnable function, we have to enable this input, player enable, and in the onDisable function, onDisable, let's just disable it. This setup ensures good logic for handled input. Typically, I put this in a game controller script, but for simplicity, it's on the player controller scope right now. In the update method, we create a method to gather input. Gather input. Let's create it. And then we create a vector2 input is equal to player input actions, player, move, read value, and the value is vector2. Why vector2? Because in Unity, we have input system actions and we have player, action move, and it's defined as a vector2 value. So whenever player gives us an input using vast left stick or joystick, we are just getting a vector2 value. Let's complete our gather input function. Now we create a variable that will be holding our input, and it's vector3 dash input. And to create it, we will have to create a new vector3 and map x to x and y to z. Now we are successfully capturing input. Let's add a debug log. Wait for Unity to compile our scripts, and let's test it. As you can see right now it's 0, and when I'm pressing something, it's getting us some values. If I were to use a gamepad, this value would be from 0 to 1, but I'm using a keyboard, so this value are either 0 or 1. Next thing we need to create is a character controller handling. Why character controller and not a rigid body? Well, it helps us to go up and down if the place is a bit uneven, and it's just more simple. You of course can make it using rigid body. There will be a small change in providing an input. In your scene, select the player and add character controller. On the top of our script, add require component type of character controller. Then we can get our character controller using get component and be sure it's safe. Next thing, we create a character controller variable, and in the awake function, we are getting character controller using get component. Now we are ready to move our player. Let's introduce a new variable, serialized field, private, float, speed. this default value of 10. We are making it serialized so it will be visible in the inspector and we will be able to edit it whenever we want. And since we are not using a rigid body, we'll use the update method instead of fixed update. So let's create a new method, move, not this one, and generate it. And inside it, let's create a vector-free move direction variable, which will be equal to transform.forward multiplied by our speed and multiplied by input.magnitude. So whenever player will be giving us any input, the player character controller will be moving. And to make it frame independent, let's multiply it by time delta time. An isometric movement is different from the normal one because the player will be moving in a different axis. You can see on the screen how it's different. Let's implement it. First of all, let's create a look function and generate it. And inside it, if the input is equal to vector 3.0, we do nothing. Because if the player is not providing us any input, we shouldn't do anything. Second, we have to create a speed rotation variable as a serialized field. I'll just copy this, rotation speed, and it will be equal to 360. And here comes our beloved math. We need to create a matrix 4x4. It's basically 4x4 dimensional array. So let's do that. Matrix 4x4 isometric matrix, and it's equal to matrix 4x4 rotate quaternion earlier, and we rotate it by 45 degrees on y-axis. If you're interested why we are doing this math, check the video in the description, it will be explained in details. Next, we transpose this matrix by multiplying it by vector 3 using multiply point 3 by 4 by our input. It will be easier shown than that. Vector 3 multiply matrix is equal to isometric matrix multiply 0.3 by 4 and we providing inputs as a parameter. Now we are making quaternion rotation and it's equal to quaternion look rotation multiplied matrix, and as an upward vector we have to use vector 3.up. Finally, we can rotate our player by using transfer rotation is equal to quaternion rotate toward, so it will be smooth. And first of all, we will provide from rotation, and then we provide to rotation and rotation speed multiplied by time delta time. And let's check it out. As you can see, the player is moving forward and is rotating when I change the direction of movement. But we can also make it more smooth and nice feeling. To improve responsiveness, add acceleration. It's quite easy. First, we create two variables for acceleration and deceleration accordingly. Just as field private float acceleration factor, which will be equal to 5, and deceleration factor, which will be equal to 10. Then in each update function, we will calculate the current speed. So we create a current speed variable, and our speed is renamed to max speed. Then each update, we calculate current speed, calculate speed, let's create it. And if current speed is bigger than 0 and input vector is equal to 0, we have to decelerate. So if input is equal to vector 3.0 and current speed is greater than 0, we are removing from current speed a deceleration factor, multiplying it by time delta time. Else if input is not 0, else if input not equal to vector 3.0 and current speed is less than max speed, then we add to current speed acceleration factor multiplied by time delta time. And after that, just to make sure, we clamp this value between 0 and max speed so it won't get out of the boundaries. Just like current speed is equal to mass F, clamp, current speed, 0, max speed. Now movement feels smoother. Let's check it out. And of course, we have to change current speed to speed because I've changed the name and current speed. Now it's working. As you can see, there is a little acceleration and deceleration factor when I'm providing some input. You can adjust these values later so your movement would be unique. Dashing is far more complex because we have to make sure player won't be spamming dashes all the way around. We need few variables: dashing speed, dashing time, dashing cooldown, and dashing input. Let's create them. I'll just create a header for dash and then few variables: private, float, dashing speed, which will be equal to, let's say, 12. Serialized field, private float, dashing cooldown, which will be equal to 1.5, and serialized field, private float, dashing time, it will be equal to 0.2. And for our purposes, we'll be also needing private bool can dash to make sure we have cooldown, and private bool is dashing, and of course input bool dash input. Let's start with that. Let's go to the gather input function, and dash input will be equal to player input action, player sprint is pressed. It will return a boolean value whenever the key is pressed. It's already created for us in input system action. Let's see here, we have sprint and left shift and left stick press. Now that we have our input, we need a coroutine. It's basically a standard function which can wait without stopping other processes and perform other things, but we need only waiting functionality for now. So to do so, we type start coroutine in the update function and provide the name of our method. It will be dash. So let's create it, enumerator dash. Because it's coroutine, its output value is enumerator instead of just void or any other value. Now we have to do a few things. First of all, can dash should be set to false because we are dashing right now. And at the top of our function, can dash should be set to true. And then we are returning yield return new wait for second, and it should be dashing cooldown. So what's happening right here? We are setting this variable to false and then waiting for few seconds and then setting this variable to true. So when we have our input, if input and can dash, we will invoke this start coroutine function. Dash input, of course. So the next thing we want to do is to set is dashing to true and then wait for another few seconds. Wait for seconds, dashing time. And after that, is dashing should be set to false. Next, when dashing, I want player not to move in a standard way, but just dash. So I use character controller.move and provide almost the same logic as in our move function, except for normal speed, I use a dashing speed. And that's only if player is dashing. So in our move function, let's use if is dashing, then return and use character controller.move transform.forward multiply by dashing speed and multiply by time data time. And the dash is actually not happening because we have to set can dash to true at the beginning of our function. Now it's ready. I also noticed that my max speed is greater than our dashing speed, so I will change that and make dashing speed to 8. And then when I press shift, it dashes. And when I move and press shift, it sprints. And I cannot spam shifts, so that works as intended. And now we have few problems. First of all, our player levitates. And second, when we go on an uneven plane, player does not fall. Uneven planes are handled by character controller. It's a slope limit that controls it. And we have to implement our gravity. We can use Unity default one, but I prefer to have it customizable. Just here, serialized field, private float gravity, and it's equal to -981. After that, let's create a velocity vector free variable. And if our player is grounded, which we can check using is grounded property in our character controller, and if it's grounded, and velocity is below 0, let's just set it to velocity.y, of course, because we are moving along y-axis while falling. And let's set velocity y to -2. It just feels okay. And if we are not grounded, let's set velocity.y to gravity multiplied by time delta time. And then in a move function, add velocity to our move direction, just like that, velocity, and the movement is done. Now the player can fall, and slopes, as I said, handled by character controller. And we can customize gravity and all other parameters, so our fall would be customizable too. And for the second problem, we just need to change character controller's Y value, because right now you can see our player levitates. So I move character controller's collider a bit higher, and the player won't be levitating, just a bit more. And right now, our movement is ready. That's it. Feel free to ask questions in the comments, and I'll happily help. See you in the next video. Ciao!